To start, it's crucial to determine the existing wiring configuration. Begin by inspecting the breaker panel to ascertain whether the bathroom circuit is isolated from other rooms. If the bathroom circuit is indeed separate, you can proceed with installing a ground fault circuit interrupter, abbreviated GFCI receptacle, without concerns about it affecting other areas. However, if the bathroom circuit extends to multiple rooms, a more detailed investigation is required to understand how the other outlets are wired. To achieve this, you can use a non-contact voltage tester to trace the wires and identify any branch circuits connected to the bathroom outlet. Carefully remove the receptacle cover and visually inspect the wiring connections, paying close attention to wires connected to terminals marked line or load. If you're uncertain about any aspect of the wiring, it's best to consult with a licensed electrician who can provide expert guidance. Once you've accurately determined the wiring configuration, the next step is to install the GFCI receptacle. Before beginning any electrical work, ensure that the power to the bathroom circuit is turned off at the breaker panel. Remove the existing receptacle cover and unplug any devices that are connected to it. Disconnect the wires from the old receptacle, carefully noting the location of each wire, including the line, load, and ground wires. Connect the wires to the new GFCI receptacle following the manufacturer's instructions. The line wires should be connected to the line terminals, the load wires to the load terminals, and the ground wire to the ground terminal, which is typically marked with green or bare copper. Securely mount the GFCI receptacle inside the electrical box and replace the cover plate. Finally, restore power to the circuit at the breaker panel and test the GFCI outlet by pressing the test button. The outlet should trip, indicating that it's functioning correctly, and reset when the button is released. It's essential to consider the implications for other rooms if the bathroom circuit extends beyond the bathroom itself. Installing a GFCI receptacle in this scenario might not be the most suitable solution, as it could lead to unwanted or false tripping of the outlet due to ground faults in other parts of the circuit. Instead, explore alternative options to provide GFCI protection without disrupting other areas. One option is to install GFCIs in downstream outlets within each room connected to the circuit. This approach offers localized GFCI protection for each room individually, without affecting the main incoming circuit. Another option is to install a whole house surge protector. This device can help prevent power surges and ground faults throughout the entire electrical system, thereby reducing the risk of tripping circuit breakers in GFCI outlets. While this provides surge protection, it may not fully address ground fault protection in specific areas like a GFCI would. As a more comprehensive solution, consider rewiring the electrical system. This is a more involved and potentially expensive undertaking, but it can ensure that the wiring meets current electrical codes and provides adequate protection against electrical hazards throughout the mobile home. Before undertaking any electrical work, it's crucial to understand the fundamental principles of electrical safety. Always disconnect power at the breaker before working on any electrical components. Use insulated tools to prevent accidental shocks. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are unfamiliar or uncomfortable with electrical work, consult a qualified electrician to ensure that the job is done safely and correctly. Electrical codes and regulations vary by location. Check with your local authorities or a qualified electrician to ensure that your work complies with all applicable codes. Mobile homes may have specific electrical requirements that differ from standard residential buildings. Be sure to research and comply with any specific regulations for mobile homes in your area. When working with electrical wiring, it is essential to correctly identify the different types of wires. The line wires, also known as hot wires, carry the electrical current from the power source to the outlet. The load wires carry the electrical current from the outlet to the devices plugged into it. A neutral wire provides a return path for the electrical current back to the power source. The ground wire provides a path for stray electrical current to flow safely to the ground, preventing electrical shocks. Ground fault circuit interrupters, abbreviated GFCIs, are designed to protect people from electrical shocks by detecting ground faults, which occur where electrical current flows through an unintended path, such as a person's body. When a GFCI detects a ground fault, it quickly trips the circuit, cutting off the flow of electricity and preventing a potentially fatal shock. GFCIs are typically required in areas where there is a high risk of exposure to water, such as bathrooms, kitchens, and outdoor locations. Regular testing of GFCIs is essential to ensure that they are functioning correctly. To test a GFCI, press the test button on the outlet. The outlet should trip, cutting off the flow of electricity. To reset the GFCI, press the reset button. If the GFCI does not trip when the test button is pressed, or if it cannot be reset, it should be replaced immediately. In addition to GFCIs, surge protectors can help protect your electronic devices from damage caused by power surges. Power surges are sudden increases in voltage that can damage sensitive electronic components. Surge protectors work by diverting excess voltage away from your devices, protecting them from damage. Surge protectors are available in a variety of types, including whole-house surge protectors and individual outlet surge protectors. Whole-house surge protectors are installed at the main electrical panel and protect all of the devices in your home from power surges. Individual outlet surge protectors are plugged into individual outlets and protect only the devices that are plugged into them. When selecting a surge protector, look for one that has a high surge current rating, which indicates the amount of surge current that the protector can handle. It is also important to choose a surge protector that is UL listed, which means that it has been tested and certified to meet safety standards. Rewiring an electrical system is a complex and potentially dangerous task that should only be performed by a qualified electrician. Rewiring involves replacing old or damaged wiring with new wiring, and it may also involve upgrading the electrical panel to accommodate increased electrical demand. Rewiring can improve the safety and reliability of an electrical system and can also increase the value of a home. When planning to rewire an electrical system, it is important to obtain the necessary permits from your local building department. A qualified electrician can help you obtain the necessary permits and ensure that the rewiring is done in accordance with all applicable codes. Aluminum wiring was used in some homes built in the 1960s and 1970s. Aluminum wiring is more prone to corrosion and overheating than copper wiring, and it can pose a fire hazard. If your home has aluminum wiring, it is important to have it inspected by a qualified electrician. An electrician can determine whether the aluminum wiring is safe or whether it needs to be replaced with copper wiring. There are several ways to mitigate the risks associated with aluminum wiring. One option is to install copper connectors at all of the connections between the aluminum wiring and the devices or appliances. These connectors create a more secure and reliable connection that reduces the risk of overheating. Another option is to replace the aluminum wiring with copper wiring. This is the most expensive option, but it is also the safest and most reliable. Electrical panels, also known as breaker boxes, are the central distribution point for electricity in a home. The electrical panel contains circuit breakers, which are designed to protect the electrical circuits from overloads. When a circuit breaker trips, it cuts off the flow of electricity to the circuit, preventing damage to the wiring and appliances. Electrical panels should be inspected regularly by a qualified electrician to ensure that they are in good working order. If an electrical panel is old or damaged, it may need to be replaced. When replacing an electrical panel, it is important to choose a panel that is sized appropriately for the electrical demand of the home. A qualified electrician can help you determine the appropriate size of electrical panel for your home. Electrical codes require that all electrical work be performed in accordance with the National Electrical Code, NEC, which is a set of standards for safe electrical installation. The NEC is updated every 3 years, and it is important to stay up to date on the latest changes. A qualified electrician will be familiar with the NEC and will ensure that all electrical work is performed in accordance with the code. Before starting any electrical project, it is important to plan the project carefully. Determine the scope of the project, the materials needed, and the tools required. It is also important to consider the safety aspects of the project and to take appropriate precautions. If you are unsure about any aspect of the project, consult with a qualified electrician. When working with electrical wiring, it is important to use the correct tools. Use insulated screwdrivers, pliers, and wire strippers. Wear safety glasses to protect your eyes from flying debris. And always disconnect the power before working on any electrical circuit. When connecting wires, it is important to make sure that the connections are secure and that the wires are properly insulated. Use wire connectors to connect wires together. Wrap electrical tape around the wire connectors to insulate the connections. When installing electrical outlets, make sure that the outlets are properly grounded. The ground wire should be connected to the ground terminal on the outlet. When installing light fixtures, make sure that the fixtures are properly supported. The fixtures should be attached to a ceiling joist or wall stud. When installing appliances, make sure that the appliances are properly grounded. The ground wire should be connected to the ground terminal on the appliance. When using extension cords, make sure that the cords are sized appropriately for the appliances that are being used. Do not overload extension cords. Inspect extension cords regularly for damage. Replace damaged extension cords immediately. When using portable generators, make sure that the generators are properly grounded. Do not operate portable generators indoors or in enclosed spaces. Carbon monoxide from portable generators can be deadly. If you have any questions about electrical safety, consult with a qualified electrician. An electrician can provide you with valuable information and advice on how to stay safe around electricity. Remember, electricity is a powerful force that can be dangerous if not handled properly. Always take precautions when working with electricity. Mobile homes often have unique electrical considerations compared to site-built homes. Due to the manufactured nature of mobile homes, the wiring may be more compact and accessible. It's crucial to be aware of these differences when working on electrical systems in a mobile home. One important consideration is the grounding system. Mobile homes typically have a grounding system that is connected to the metal frame of the home. It's essential to ensure that this grounding system is intact and functioning properly to prevent electrical shocks. Another consideration is the type of wiring used in mobile homes. Older mobile homes may have aluminum wiring, which, as mentioned earlier, can pose a fire hazard. If your mobile home has aluminum wiring, it's recommended to have it inspected by a qualified electrician. When replacing electrical outlets or fixtures in a mobile home, it's important to use components that are rated for use in mobile homes. These components are designed to withstand the vibrations and movement that can occur in a mobile home. Additionally, it's important to properly secure all wiring and connections to prevent them from coming loose during transport or movement of the mobile home. Before making any electrical modifications to a mobile home, it's crucial to consult with a qualified electrician who is familiar with the specific electrical requirements for mobile homes in your area. They can ensure that the work is done safely and in compliance with all applicable codes. When working on electrical systems in a mobile home, it's also important to be aware of the potential for hidden wiring or plumbing. Use caution when drilling or cutting into walls or ceilings to avoid damaging these systems. If you are unsure about the location of wiring or plumbing, consult with a qualified electrician or plumber before proceeding. By taking these precautions, you can ensure that electrical work in a mobile home is done safely and correctly. It's important to remember that electrical codes and regulations can vary by location, so it's always best to consult with a qualified electrician to ensure that your work complies with all applicable codes in your area. In addition to the points already covered, it is beneficial to remember electrical safety guidelines. Firstly, always turn off the power at the breaker box before working on any electrical circuit. Secondly, use insulated tools to avoid electric shock. Thirdly, never work on electrical systems when you are wet or standing in water. Fourthly, inspect electrical cords and plugs regularly for damage. Fifthly, replace any damaged cords or plugs immediately. Sixthly, do not overload electrical outlets or circuits. Seventhly, use extension cords only temporarily and do not run them under rugs or furniture. Eighthly, keep electrical appliances away from water. Ninthly, teach children about electrical safety. Tenthly, if you are unsure about any electrical work, consult a qualified electrician. Always remember that electrical safety is crucial for protecting yourself and your family from harm. It is always better to be safe than sorry when it comes to electricity. By following these safety guidelines, you can help prevent electrical accidents and ensure that your home is electrically safe. Also, understanding basic electrical concepts. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of electrical current. It is measured in ohms. Ohm's law states that the voltage across a resistor is equal to the current through the resistor multiplied by the resistance of the resistor. Power is the rate at which electrical energy is transferred. It is measured in watts. Understanding these basic electrical concepts can help you troubleshoot electrical problems and make informed decisions about electrical work. However, it is important to remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are unsure about anything. By taking the time to learn about electrical safety and basic electrical concepts, you can help protect yourself and your family from harm and ensure that your home is electrically safe. Before undertaking any electrical work, it's also crucial to consider the potential impact on other electrical systems in your home. Changes to one circuit can sometimes affect the performance of other circuits, especially in older homes with outdated wiring. For example, adding a new high-power appliance to a circuit can overload the circuit and cause the circuit breaker to trip frequently. It's important to assess the capacity of your electrical system and ensure that it can handle the additional load before making any significant changes. If you're unsure about the capacity of your electrical system, consult with a qualified electrician who can perform a load calculation and recommend any necessary upgrades. Also, consider the location of your electrical panel. The electrical panel should be easily accessible in case of an emergency. It should also be located in a dry, well-ventilated area. Do not store flammable materials near the electrical panel. And never block access to the electrical panel. Keep the area around the electrical panel clear of obstructions. This will allow you to quickly shut off the power in case of an emergency. When choosing electrical devices and appliances, look for those that are energy efficient. Energy-efficient devices and appliances can save you money on your electricity bill and reduce your carbon footprint. Look for the Energy Star label when shopping for electrical devices and appliances. The Energy Star label indicates that the device or appliance meets certain energy efficiency standards. Regularly inspect electrical cords and plugs for damage. Replace any damaged cords or plugs immediately. Damaged cords and plugs can pose a fire hazard. Do not use electrical devices or appliances that have damaged cords or plugs. If you notice any signs of electrical problems, such as flickering lights, sparking outlets, or burning smells, call a qualified electrician immediately. Do not attempt to repair electrical problems yourself. Electrical problems can be dangerous and should only be repaired by a qualified electrician. Remember, electricity is a powerful force that should be treated with respect. By following these safety tips, you can help protect yourself and your family from harm and ensure that your home is electrically safe.